Hello, welcome back. In the last video, we were discussing what is meant by a location family of distributions. Here, we shall discuss a scale family of distributions. We have seen in location family of distributions, when location changes, the probability curve shifts either to right side or left side without changing the shape of the distribution. But here in the scale family, the scale parameter will influence in another way. And before going to the discussion of the shape of the distribution, we shall define what is meant by a scale family. A scale family of distribution has a PDF of this form: g of x sigma, which is equal to 1 by sigma f of x by sigma, where sigma greater than 0, where f is a PDF. And this standard deviation, the not standard deviation, in many cases it may be standard deviation but not in general. The parameter sigma is called the scale parameter of the family. Okay, now you see what is the change we are going to make in the scale family of distribution with respect to the standard distribution with density f. In this new density, we multiplied the old density with 1 by sigma and then replace x by sigma. You remember, in the location family we were replacing x by x minus mu, where mu is the location parameter. Here we are not only replacing x by x divided by sigma, but we are multiplying this with 1 by sigma. So these two changes we have to make in the density function f, from which we start to construct such a family. Okay, now we can illustrate this by means of some examples, and of course first we take the normal density. Indeed, you see the standard normal distribution, which is equal to f of x 1 divided by root of 2 pi e to the power of minus x by 2. X varies from minus infinity to infinity. This is the standard PDF of normal distribution with the mean 0 and standard deviation 1. And you see how we construct a scale family out of this distribution f of x. You construct the new PDF by g of x sigma, and remember sigma should be greater than 0. And what you are doing, you are first taking 1 by sigma, then f of x by sigma, that is you are replacing x by sigma, and you pre-multiply this f with 1 by sigma. And what is the resulting distribution? It is 1 by sigma into root 2 pi e to the power of minus x square by sigma square, minus infinity less than x less than infinity, sigma greater than 0. Now you please make a change here. In this density I have made a mistake, that is e to the power of minus 1 by 2 into x square by sigma square. You please make the correction. Okay, and you see the resulting distribution is a family of normal distribution with the mean 0 and standard deviation sigma. This standard deviation sigma may be any number, any positive number, positive real number. Okay, so such a family is constructed, and this family is called a scale family of distribution, and the parameter sigma is called the scale parameter. Okay. And what is the effect of change of the sigma? You have seen that when you change the location parameter, the curve shifts either to right side or to left side without changing the shape of the curve. But here you see that by introducing a scale parameter sigma, it is either stretch or contract. Stretch when sigma greater than 1 and contract when sigma less than 1. That means the graph of the PDF will still have the same shape of the graph. That is, the basic shape of the graph will not be changed by changing the scale parameter. Okay. But you see that it is either contracting or stretching. And you can see an example for this in figure 3. Okay, figure 3. You see, figure 3. We are having some members of the scale family of normal distribution still with mean is equal to 0. ഇവിടുത്തെ ഈ നോർമൽ കേർവ്സിന് ഉള്ള പ്രത്യേകത എന്ന് പറയുന്നത് ചില നോർമൽ കേർവ്സൊക്കെ വളരെ കോൺട്രാക്റ്റ് ചെയ്ത് കിടക്കുന്നുണ്ട്, എന്നാൽ ചിലതൊക്കെ വല്ലാതെ സ്ട്രെച്ച് ചെയ്ത് കിടക്കുന്നുണ്ട്. അപ്പം ബേസിക് ഷേപ്പ് മാറുന്നില്ല, പക്ഷേ മൊത്തം കർവ് ഒന്നുകിൽ കൺട്രാക്റ്റ് ചെയ്യുന്നു അല്ലെങ്കിൽ സ്ട്രെച്ച് ആവുന്നു. അതാണ് ഈ സ്കെയിൽ പാരാമീറ്ററിൻ്റെ ഇൻഫ്ലുവൻസ് എന്ന് പറയുന്നത്. ആൻഡ് വി കം ടു അനദർ എക്സാമ്പിൾ with respect to normal distribution, with respect to exponential distribution, whose PDF is f of x e to the power of minus x, x greater than 0, 0 elsewhere. And you see, this is a standard exponential distribution. The exponential distribution may have the form f of x equal to lambda into e to the power of minus lambda x, and if you put lambda is equal to 1, you get this PDF. Okay, this is a standard PDF of exponential distribution. From this we can construct a scale family of exponential distribution. For that purpose you have to make g of x sigma. You have to define a new PDF which is equal to 1 by sigma into f of x by sigma, where f is given here. That means you are pre-multiplying this function with 1 by sigma, and you replace x by sigma, so that you are getting this 1 by sigma e to the power of minus x by sigma, x greater than 0 and sigma greater than 0. And you can easily verify that this is a PDF. Okay, this is a PDF. In order to show that this is a PDF, what you have to do? You have to show that this function gx is greater than or equal to 0 and integral of gx with respect to x equal to 1. That you can easily verify, and I leave the verification for you. Okay, so we have considered so far a location parameter and a scale parameter families. Okay, and you can change the scale as well as location parameters by making some changes of the standard density in that family, and such a family will be called a location scale family of distributions. And the definition is very straightforward. Let f of x be a PDF, then for any mu lies between minus infinity and infinity, and for any sigma greater than 0, then the family of PDFs g of x mu sigma, that is equal to 1 by sigma into f of x minus mu by sigma. ഇവിടെ ഈ സിഗ്മ ഗ്രേറ്റർ ദാൻ 0 എന്ന് കൊടുക്കേണ്ട കാര്യമില്ല, ജി ഓഫ് എക്സ് മ്യൂ സിഗ്മ എന്ന് മാത്രം കൊടുത്താൽ മതി. കാര്യം സിഗ്മ ഗ്രേറ്റർ ദാൻ 0 എന്നുള്ളത് നമ്മളിവിടെ കൊടുക്കുന്ന റെസ്ട്രിക്ഷനാണ്, അതിവിടെ ഫംഗ്ഷനിൽ കാണിക്കണമെന്നില്ല. ഓക്കെ, ആൻഡ് വാട്ട് ഇസ് ദിസ്? ഇവിടെ നമുക്ക് രണ്ട് കാര്യങ്ങൾ ചെയ്യണം. ഒന്ന്, യു ഹാവ് ടു പ്രീ മൾട്ടിപ്ലൈ എഫ് വിത്ത് 1 by സിഗ്മ, ആൻഡ് യു റീപ്ലേസ് എക്സ് ബൈ എക്സ് മൈനസ് മ്യൂ ബൈ സിഗ്മ. if you are replacing x by x minus mu only, and if you are not pre-multiplying, you are making the change of origin. That means a scale family, a scale parameter we are changing. And while you are dividing this by x minus mu by sigma and pre-multiplying by 1 by sigma, you are changing the scale parameter also. Okay, so this is a family of PDF indexed by the parameter mu sigma, and such a family is called location scale family with a standard PDF f of x. Okay, and the parameters mu and sigma are respectively called location and scale parameters. You can have examples. Now we shall consider only one example now, and more examples we will discuss next. Example 5, we start with a standard PDF. Okay, and you define gx mu sigma by pre-multiplying this function f of x by 1 by sigma and replacing x by x minus mu by sigma, that is 1 by sigma f of x minus mu by sigma, that is equal to this. Okay, and here you are how to restrict mu to be minus infinity to infinity, any real number, and sigma to be any positive real number. And this family is called normal distribution family with the scale parameter sigma and location parameter mu. Okay, and some members of this family is represented in figure 4. You see, you can see figure 4. Yes, this is figure 4. Here you can see some members of the location scale family normal mu sigma. ഇവിടെ സീറോ മീനുള്ള ഫാമിലിയിൽ നിന്ന് ഡിസ്ട്രിബ്യൂഷനിൽ നിന്ന് മറ്റ് ഡിസ്ട്രിബ്യൂഷൻസ് എങ്ങനെ വേറിട്ടിരിക്കുന്നു എന്നുള്ളത് മനസ്സിലാക്കാം. ചിലതൊക്കെ ലൊക്കേഷൻ ഷിഫ്റ്റ് ചെയ്തിട്ടുണ്ട്, ലെഫ്റ്റിലോട്ട് പോയിട്ടുണ്ട്, റൈറ്റിലോട്ട് പോയിട്ടുണ്ട്. ചിലതൊക്കെ അതിൻ്റെ റൈറ്റിലേക്ക് പോവുകയും അതോടൊപ്പം തന്നെ സ്റ്റാൻഡേർഡ് ഡീവിയേഷൻ മാറുകയും ചെയ്തിട്ടുണ്ട്. ഓക്കെ, അപ്പോൾ ഞാൻ വളരെ കുറച്ച് മെമ്പേഴ്സിനെ മാത്രമേ ഇത് നോട്ട് ചെയ്തിട്ടുള്ളൂ, കാരണം അതർവൈസ് ദ ഗ്രാഫ് വിൽ ബി വെരി മച്ച് കോംപ്ലിക്കേറ്റഡ്. ആൻഡ് യു ക്യാൻ സീ ദാറ്റ് ഈച്ച് കർവ് ഹാസ് എ ഷിഫ്റ്റ് rightwards or leftwards, and the curve have been stretched or contracted. Okay, so this is the influence of change of a location parameter and scale parameter in the family of normal distributions. Okay, as a summary, you can see that you can either shift the curve without changing the shape of the curve, either rightwards or leftwards, or sometimes you can stretch the curve or contract the curve. Sometimes you can do both in such a family, where the family is called location scale family of distributions. And you will see more examples for location scale family, and location family, etc. in the next video. Okay, thank you.